This is a chimera. It's a Greek mythological monster that's part lion, part dragon, and part goat. This is also a chimera. It's a female anglerfish that's mated with a male. And so is this. It's a person who's just recently undergone a bone marrow transplant. So what do all of these have in common? They all have a distinct part of them that doesn't seem to quite belong. This is the idea surrounding the definition of a chimera in genetics, which is a single organism composed of cells with distinct genotypes. Considering that it's generally accepted that all the cells in our bodies have the exact same set of DNA, the concept of the chimera is pretty revolutionary and surprisingly common. I'm serious. It all sounds a little Frankenstein, but it's a natural part of the reproductive process of the anglerfish. When a male anglerfish matures, he has to successfully utilize his sensitive olfactory senses to find a female, or he'll die. Once he does, he latches on, biting into her skin and releasing an enzyme that digests the skin of his mouth and of her body, melding them together. Even though the male anglerfish loses his jaw and vital organs, he gains access to nutrients from the female through the fusion of their vascular systems, while the female now has easy access to a sperm bank for reproduction. Since each organism has a different set of DNA, and they have now fused, the anglerfish conglomerate is now a chimera. This phenomenon can occur in humans, too. In fact, any patient who receives a bone marrow transplant will have their own infected bone marrow completely eradicated to be replaced by the donor's bone marrow. The new bone marrow will proceed to manufacture blood cells that still carry the donor's DNA. In a case of complete chimerism, all the recipient's blood cells have the donor's DNA. In a case of mixed chimerism, the blood contains mixed DNA from both the recipient and the donor. And there have also been documented cases where one embryo of a pair of fraternal twins dies early on in the pregnancy. Then, the other embryo can absorb some of the cells from the deceased one, and once it is born, the baby has two sets of DNA. So, chimeras are pretty cool, but what's even cooler is how this information is being used. Researchers are making huge strides in immunotherapy, which utilizes the patient's own immune system to attack a disease. This is being applied with great success to cancer through chimeric antigen receptor T cells, or CAR-T. T cells are the generals of the immune system. When the receptors on their surface contact the specific antigens on a pathogen, they mobilize a response. CAR-T takes this further. The T cells are genetically re-engineered to also have receptors that can detect and kill cancer cells, making them chimeric. Scientists can harvest T cells from cancer patients, modify them to target the particular antigens on the tumor, and infuse them back into patients to carry out the specified attack. This has been used successfully many times, and has been approved as a lymphoma treatment. Greek monsters, anglerfish, regular people, a cure for cancer. Different parts, all working together. Chimeras are more likely than we think, and are slowly changing the world in the way we see it.